Hi, and welcome to Solar for Lawmakers. I'm State Representative Rep Tisdel. We're going to walk through the production and manufacturing of solar energy and see if you think it makes sense for Michigan. One of the first things you'll hear about solar energy all the time is that it's clean. And let's talk about that for a little bit. So, to make solar panels, you start off with quartz. Raw quartz, and that has to be mined. So this is that has to be mined. Who's doing the mining of this raw quartz? Well, China controls half of the world's or more metallurgical grade silicon production. So in China, who's manning all these shovels mining this quartz? In the Xinjiang province of China, they're hiring a Muslim sect called Uyghurs. Actually, this is forced labor. There are about 1 million Uyghurs in China that are held in detention camps. Thousands and thousands and thousands of Uyghurs are used to mine and smelt raw quartz into metallurgical grade silicon. So we go from the raw quartz down to the smelting process. And so how does this become metallurgical grade silicon, or MgSi? Here's what happens. You need 2.5 tons of raw quartz. You need about 1.5 tons of coal, and you need about 1.5 tons of charcoal or wood chips. In this production process, obviously, when you burn the coal and when you burn the wood chips, you're giving off an awful lot of CO2 into the atmosphere. But this is what's required. 1 ton of metallurgical grade silicon needs this combination, this recipe of material to produce. That's how you get your metallurgical grade silicon. Metallurgical grade silicon is about 99% pure, but that's not sufficient to build solar panels. So now we have to go from metallurgical grade silicon to polysilicon or polycrystalline silicon, which is 99.9999% pure. So how do we do that? Over a series of days, this metallurgical grade silicon is smelted further using 10 times the amount of energy that was used originally to make the metallurgical grade silicon. So we get this polysilicon. You go through this process, and it delivers a brick or a loaf of polysilicon. Sounds like we're done? Not quite yet. The polysilicon then has to become what's called a mono PV photovoltaic, or we turn the polysilicon into one single large crystal that then becomes that's the mono PV or the mono photovoltaic. So now this process takes another 6 times the amount of energy that's used up over here. Not quite clean yet. So now you get a brick of mono PV. That mono PV then is sliced using wire saws into the very thin wafers that make up the solar cells. During this process, half of the mono PV goes to the landfill as unrecoverable or non-recyclable sawdust. So you go through all of this process, all of this energy, all of this CO2 to deliver half of the product to the landfill as sawdust. By the way, we were talking about CO2 over here. During this process, the polysilicon to the mono PV, the creation of polysilicon to the mono PV, we give off something called perfluorinated compounds. I'm not going to give you the names. Suffice it to say that these are in the PFAS family. These perfluorinated compounds are thousands of times more potent in the atmosphere than CO2. Forced labor, CO2, PFAS, landfill. If you don't like forced labor, if you don't like atmospheric CO2, if you don't like PFAS, and you don't like more toxic waste that can't be recycled in the landfill, you don't like solar. Okay, so we've talked about solar energy as being clean, quote, end quote. And again, if you don't like CO2, if you don't like PFAS, if you don't like forced labor, if you don't like toxic waste in the landfills, you don't like solar. But the other part we hear about is that solar is cheap. It's inexpensive. It's the least expensive means of adding more electricity to our electrical grid. Let's talk about that a little bit. So the first thing we're going to talk about is capacity. Whenever you read about solar, or wind for that matter, but let's stick with solar, whenever you read about solar arrays or solar panels being installed, they will always talk about the quantity in terms of capacity. Let's say it's 1 megawatt of capacity that's being installed. Well, capacity is one thing. What is that capacity actually going to produce? Well, in the state of Michigan, we rank 42nd in the US in state sunlight. In fact, we have about 71 clear sky days a year, and for the state as a whole, we average about 4 hours of maximum sunlight a day, maximum production sunlight a day. So when we talk in terms of capacity, this 1 megawatt in the state of Michigan, what we actually get on average is 18% of the capacity in actual electrical production, electricity production from solar panels. Let's put it this way. Let's say I'm your father, and I come to you and I say, you know what? I have the capacity to give you $100 a month allowance. First month rolls around, you're all excited, and I come in and I present you with $18. Now you're going to say, Dad, you're lying to me. No, I told you I had the capacity to give you $100, but I'm only giving you 18. And oh, by the way, during the winter months, that's going to become $4.90 because that's what happens to our 18% average in the winter months becomes 4.9%. So we have this field of solar panels. This is what we're actually producing. When the utilities come to the state and are asking for subsidy dollars to help transition from fossil fuel electricity sources to solar, they're asking for subsidy dollars based on capacity. They're not going to accept subsidy dollars based on actual megawatt or kilowatt hours produced, because the amount of dollars that you would have to give them per kilowatt hour, what's actually delivered as dispatchable energy to end users, residences, industrial, commercial buildings, the dollar amounts would just be through the ceiling, and people wouldn't stand for it. So this is what we're talking about. We're talking about a not clean product coming in to deliver a not cheap end result. You'll see this all the time. Solar is the least expensive way of adding more electricity to the system. And you'll see, oh, coal costs this much. Natural gas costs that much. Wind costs that much. And oh, and then beautiful solar only costs that much. One problem: these fossil fuel sources have to keep running 100% of the time, because, as we've indicated with solar, you're only getting a small delivery of the actual capacity that's been installed. In fact, as I said up here, when you look at these, on average, we have 4 hours of maximum production time a day. So the sun is rising. There's very little energy, solar energy, being produced at this time. You get up to this 4-hour wedge, that's your maximum production as the day. As the sun starts to set, again, you're getting less and less production out of the solar irradiance in the state of Michigan that's ranked 42nd in the US. So in this little window is where there's maximum production. What do you do during these parts, or after the sun is down and you're waiting for it to come back up? You know, when it's here, this is delivering 0% of capacity, right? What do you do in those times when there's limited production or zero production? You count on the fossil fuel backup that's running 100% of the time. It's not clean. It's not cheap. Solar is an expense that's on top of the fossil fuel delivery sources that we already have in place. If you think this sounds like a good idea, let me give you one more piece of information. The state's Michigan Healthy Climate Plan that EGLE, the Department of Environmental, Great Lakes, and Energy, put out in April of 2022. By 2030, consumers claims they're going to install 8 megawatts capacity of solar. DTE is claiming they're going to install 10 million solar panels. What that works out to in capacity, I don't know, but it's 10 million panels. So by 2030, this is what our utilities have committed to. That's 2040. 10 years earlier, 2030, The governor's plan calls for 2 million EVs to be sold and registered in the state of Michigan. So let's think about this. There's a 10-year spread between 2040 and 2030. There are 35,000 EVs registered in the state of Michigan right now. So in the next 6.25 years, somewhere between now and 2030, there's another 1,965,000 EVs going to be sold and registered in the state of Michigan. Okay, let's say that actually happens. You've got 2 million electric vehicles coming home after work to plug in to be, here's your plug, electrical, they're going to plug in to be recharged, and the electricity that we're adding is solar, which is in bed, tucked away for the night, delivering zero production. This is the plan. It's not clean, it's not cheaper, and it makes absolutely little or no sense. That's solar for lawmakers. Thank you.